Hello, I'm Joseph Casa, and I'd like to welcome you to Session 0 of my Writing Good Requirements course. This session is an introduction and an overview. So the objectives of this session are to introduce the course, tell you all about it, to provide an overview of the sessions and how they fit together, to provide details of the content of at least 2 sessions, to explain the structure of the course, which you'll find is different to every other course you have taken or you're planning to take, and lastly, to briefly explain why and how the course was developed. The outcomes are, on completion of this course, you should be able to write good requirements more than 90% of the time, write well-written requirements more than 96% of the time. I'm not promising you 100%. But I'm promising you can get very close. You'll be able to elicit good requirements from stakeholders. You'll better understand the stakeholder need, and you'll be able to convert more than 90% of poorly written requirements into well-written requirements. And that comes very useful during the requirements elicitation and elucidation phases or states of the system lifecycle, as well as when you're writing test plans and test procedures. And you'll understand the importance of stakeholders, and you'll be able to identify and manage stakeholders, and most importantly, you'll understand why writing good requirements has been so difficult in the past. There are 10 sessions. The first session introduces you to requirements. The second session discusses stakeholders and their importance. Session 3 discusses how to identify the stakeholders' wants and some of the things they don't want but they might need. Session 4 is converting stakeholder wants to needs, how you go about doing that. Session 5 discusses where you document the stakeholder needs. It doesn't necessarily have to be a model, although you do have to know some things about modeling. Session 6 helps you convert stakeholder needs to requirements. Session 7 discusses converting the requirements to well-written requirements. Session 8 covers converting well-written requirements to good requirements. Session 9, the use of requirements in the rest of the system development process. So you start to learn the consequences of poorly written requirements. And Session 10 is a summary, an update, and the closeout. Session 1 starts with an exercise presentation. It continues with the background to the situation, introduces glossaries and definitions of the terminology that are going to be used in this course. We discuss the purpose of requirements, and then I talk about well-written requirements, their attributes, the spelling and grammar, the structure of the requirement, and the vocabulary of the requirement. I then talk about what I call generic and system-specific requirements and their benefits. I'll then give you some examples of really bad requirements and how to fix them. Briefly remind you of the problems caused by poorly written requirements, and then I'll introduce the exercises that you'll have to do between Session 1 and Session 2. Session 2 starts with your best, missing, worst question feedback from the previous session. This may be something you've never seen before, but it's part of my continuous feedback process, and I'll explain it in the course of this lecture. Then we do the exercise presentations, and then I talk about stakeholders and lessons learned from dealing with stakeholders, some from my experience and some from the literature. Then I'll discuss where and how to locate potential stakeholders for the project, using the extended process to realize the solution system as a generic model. And I'll talk about the difference between customers and other stakeholders, information and contractual communications between stakeholders and how to manage them. That is very important to writing good requirements. We'll talk about stakeholders' wants and needs and the differences, and direct and indirect stakeholders. And lastly, the degree of influence of each stakeholder on the requirements, and then I'll introduce the exercises for Session 2. The course assumptions are: lectures summarize and point out important points. The practical activities bring the knowledge to life and provide experiential anchor points. Participants may interrupt the lecture with questions, are expected to do the homework. If you want the benefit of the course, you have to put some effort into it and you have to do the homework. Learning comes from doing, practicing and teaching, not from listening. You do the exercises and the readings. This maximizes the return on investment, your time, the fees paid for the course. The architecture of the course is optimized for maximum learning using what I call the balanced classroom. This is a result of more than 20 years of research into teaching technical subjects like systems engineering, software engineering, and even project management more effectively and efficiently for postgraduate students who are in the workplace and don't necessarily have the time that traditional students do, because you've got a job to do, you've got a family, you've got a life. You want to minimize the amount of time you spend on learning, but get the maximum benefit from it. It's designed for various learning styles, so it uses live lectures, live weekly discussion and question and answer sessions, and occasionally there are readings for in-depth knowledge. You can't expect me to cover a complicated or complex subject in depth in the lecture time, so you have readings. There are practical exercises for you to practice what you've learned. And then there are what I call knowledge reading exercises in which you present what you've read, and I'll talk about them in a moment. And there are lots of feedback to keep learning on track. So BWMQ is one type of feedback, knowledge readings are another type of feedback, practical exercises are another type of feedback. So we're making sure that your learning is going straight and you're not misinterpreting anything. In traditional classes, you only find that out at exam time at the end. This course is designed to provide education, training, and emulation of the workplace environment. I keep telling you, it's different to your traditional courses. Education increases the insight and understanding of why the task is performed. And I quote, re-engineering the corporation. Training is to improve how a task is performed by increasing the skills and competencies in performing tasks. And it's also emulation of the workplace environment, which means you have to do some reading, some thinking, doing things and communicating them. And in my EverCourse format class, the exercises can be presented as a work in progress. But since this is a live class, you have to complete the exercises in the amount of time that's allocated for them, which I'll discuss in a moment. Now, there are three types of knowledge. Declarative knowledge, which is knowing that something is the case. Describing a process is declarative knowledge. Then there's procedural knowledge, which is knowing how to do something, and it must be demonstrated by actually doing it. And so performing the process demonstrates the procedural knowledge. And then there's conditional knowledge, knowing when and why to apply the declarative and procedural knowledge. And this is from Anne Woolfolk. Most courses that you take will focus on declarative knowledge and a little bit of procedural knowledge. They tend to focus on the what and sometimes the how. This course also gives you a lot of information on the why. And the focus through the knowledge readings and part of the exercises are on the conditional knowledge. It helps you think, as I'll explain. The balanced classroom is designed to maximize the higher order upgraded Bloom's taxonomy levels. So the classroom module consists of a lecture, exercises, knowledge readings, and an individual assignment, which you won't be performing in this class. And you can see here that remembering and understanding the lower levels of the taxonomy, there's no feedback in the lecture, so we don't know whether you understood it or not. When you do the exercises, you are demonstrating, understanding, and applying, and perhaps remembering, unless you're going back to the book each time you do the exercise. But when you do the knowledge readings, you need to do a lot of analyzing, evaluating, and creating. So you're learning to think about what you're doing, why you're doing it, as well as doing it. And that's critical to writing good requirements. Are you now beginning to understand why writing good requirements is so difficult? One of the reasons is you're not being taught what you need to know. The knowledge readings, and you can watch the video for a lot more detailed information, but it's optional because I've given you enough information here to work with. Knowledge readings provide a better learning experience. Learning for the purposes of presentation is the best way of ensuring retention and understanding of the knowledge. It demonstrates that different people perceive information differently. You watch your classmates present their version of the knowledge reading, and you will be surprised. They come up with different main points. They interpret things differently. And that should teach you that when you write requirements, you've got to make sure to do your best that all the people who read the requirements perceive the information in the same way. It also enables me, the instructor, to correct any misinterpretations as they arise. Because in the knowledge reading, you will present the information and I will say, whoops, that's not what it's supposed to mean. And that's one of the reasons I update the class. I take out the ambiguity. It provides you with the opportunity to practice presentation skills and obtain feedback on content and style. Would you rather stuff up your presentations in the class or in front of your boss? And I've got very positive student feedback on this once the students understand what it is and why they're doing it. They might complain it's a lot of work, but usually the complaint that it's a lot of work is they're doing work that they didn't need to do or weren't asked to do. And that's covered in one of the readings for this session. The session knowledge, you'll see every session begins something like this with a template. There's a lecture, there are readings, and there are exercises. The lecture is the overview of the knowledge for the session. It's a summary of the readings, but not in too much detail. You get the readings from the knowledge reading exercises. It's a summary of the readings, but not in too much detail because you'll pick up the content of the readings when you do the knowledge reading exercises, and it contains material that's not in the readings. And so the first reading is the video introducing knowledge readings. It's optional, as I've said, and it takes 20 minutes. I think it's worth watching, but you don't have to if you don't want to. And then there's this one, the two biggest mistakes students make in essay examinations and in exercises and how to easily eliminate them. That's 10 minutes, and that may be the best investment of time you will make in quite a while. And then there are the exercises. You learn by doing. You learn by presenting. And you learn by teaching. Best ways of learning. And you learn from the feedback. Feedback on other people's exercises, feedback you give other people, feedback other people give you. And it's not only the instructor giving you feedback, you're getting feedback from your participants because they bring knowledge and experience into the class as well. And by the way, the file numbering convention, you see here SN-RN-PN. SN is the session number. RN is the reading number in the session. So if you look down in the bottom corner of the screen, you will see 0001-13. That tells you it's session or lecture 1, reading 1, and page number 13. Simple. The knowledge components, as I said, there's the lecture and the presentation graphics. There's audio and visual, and there's some redundancy, and there's some overlap. Some of the students will be non-native English speakers, and so they can read it as well as listening to it. And I usually embellish a little bit so that the native English speakers won't get bored with me just reading what shows up on the screen. And it provides you with some additional information as well. The readings are additional material from various sources, extracts from textbooks, etc. And the exercises. There are two types of exercises, which I'll explain in a moment. And there's best missing worst question, which I will explain in a moment. I learned this at George Washington University 25 years ago when I became a graduate teaching assistant. They gave me a training course on what to teach and how to teach and included BWMQ. And then they gave me a textbook and said, go teach the class. And by the way, don't teach the book. Interesting problem. And then you bring knowledge into the course yourself. Other students bring knowledge into the course and you share them. In the duration of the course, you're doing research as part of the exercises, and you bring that knowledge into the course and share it with everybody. I like that too, because it means I often learn something new as well. The exercises. They're sized to take no more than 60 to 90 minutes. You can get all the benefit from the exercise without going into very much detail. And so if you spend more than 90 minutes on the exercise, you must really be interested in it, or you haven't watched the Two Major Mistakes video. So watch the video. It's only 10 minutes. In this class, it does need to be 100% complete. There are two types of exercises. There's the practical, which lets you apply knowledge from the session and previous sessions. So each exercise can be cumulative. The knowledge readings, learning by teaching. The best way to learn. You get feedback on your interpretation, and it's discussed in the optional reading video, and I've already talked about it. How to deal with the exercises. I want you to use the Creating Outstanding Problem Solving class problem formulation template that I teach. Oh, that's right. You haven't been taught that because you haven't taken the class. Don't worry. I'm going to give you an example of it in a moment. Determine what needs to be done. These are the requirements for the exercise. And then you work back from the answer. You visualize, imagine, conceptualize yourself completing the exercise. What did you do right before it? And what did you do right before that? So, for example, you completed the exercise. Good. What did you do right before that? You checked that what you put into the presentation is what was required. What did you do before that? You filled in the presentation template. What did you do before that? You gathered the knowledge. You did what was required. What did you do before that? You used the template. What did you do before that? And so on and so on and so forth until you get to this state where you've been given the problem. And before you do the first exercise, I suggest you create an exercise template, because you'll find that all the exercises use the same format. And so having a template actually helps you each time, because you know exactly what you have to put in. It's described in the Systems Thinkers Toolbox session 11.8. You create a compliance matrix. That's described in Systems Thinkers Toolbox 9.5.2 and in session 1 of this course. You create the presentation template, which I've just mentioned. Systems Thinkers Toolbox session 14.6 provides one, and after you've done the first exercise, you can use that as your template. Plan the use of allotted time. Figure out how much time to allocate to each part of the exercise. Think about observations and insights from readings and prior knowledge. Produce the required presentation. Incorporate material to show that you have looked at the readings, or at least pretend you've looked at the readings or equivalent material. Citations, use author and date. That way I can see at the time who you're citing. Numbered citations are fine in journals, but in exercises I'd much rather see who you're citing as you cite them, which allows me to think about whether I've read that material, know that material, and whether it's pertinent or not, and we can discuss that in real time. Session feedback, BWMQ. Best, worst, missing questions. After the session is over and you've done the exercises, take a few minutes. Think about what was the best thing about the session, what was the worst thing about the session. Is there something missing that you expected? And do you have any questions that you didn't ask during the session? Think about each point, and if nothing comes to mind in 10-15 seconds, don't fight it, skip it, and go on to the next one. So if you can't think of something that was the best, maybe you can think of something that was worst, or something that's missing, or a question. And please email that to this email address, beyondsystemsthinking@yahoo.com. Subject is the class title, so it would be requirements. BWMQ session number, so in this instance it's session 0. So I'd now like to share with you, just for a few moments, the reasons this course was developed, and it also provides some of the background. Requirements analysis should be an activity that converts the customer's real needs to good, well-written requirements. But in general, what it tends to be is an activity that analyzes poorly written requirements to figure out what the customer really needs and then produces better requirements. Back in 2008, when I audited Robert Halligan's course, this is what he taught. And afterwards, I talked to him and said, Robert, this is very important, what you're teaching, but you also need to teach the students how to write good requirements. I haven't audited one of his courses since, so I don't know what's changed. But a lot of the courses I see, a lot of the textbooks that I see, don't teach you how to write good requirements. So the questions I have about this is why? What is so difficult about writing good requirements? And how much of that difficulty can be overcome? You've seen this drawing or versions of it, and this represents the situation. I picked this up in 1970 when I was working on the Apollo program. It's the government contracting, so the wording is government contracting. What the RFP described, how the bidder understood it, what was specified, what was designed, what was implemented, and what the customer really wanted. How much of that is still valid today? Do you think that situation has changed over the years? Well, the process was described like this. How the customer explained it, how the project leader understood it, how the analyst designed it, how the programmer wrote it, how the business consultant described it, how the project was documented, what operations installed, how the customer was billed, how it was supported, and what the customer really needed. Just more steps. The outcome is the same. Maybe the more steps are due to the software. I don't know. But I think this drawing came from Holland in the software world. It's an international problem. It's not just in the English-speaking world. I picked this one up in Israel. And since Israel writes from right to left, you can see that the figures are reversed. So what do we do about the problem? Well, let me introduce the Creating Outstanding Problem Solvers course problem formulation template. It's also shown in my book on Systems Thinking Toolbox. It's 5 parts. The undesirable situation as perceived from various perspectives, and it's discussing the objects in the situation and their relationships and what they're doing. And then I call out the assumptions. Very important. What are the assumptions about the situation, the problem, the solution, the constraints, etc.? Get the assumptions wrong and your solution will be wrong. So it's important to articulate the assumptions and have them checked by subject matter experts. The feasible, conceptual, future desirable situation. This is the conceptual, imaginary situation without the undesirability. Business process reengineering calls this the 2B model. I use the words FCFDS because I want to stress it has to be feasible, it's conceptual, and it's in the future. And then we discuss the problem. What needs to be done to convert the FCFDS to reality? in reverse order. Remember I said dealing with the exercises is work back from the answer? This is how you write the problem. And I'm going to give you an example in a moment. And then the solution is how the undesirable situation will be at the beginning when you think about it. And then at the end of the project, if you have the time and the need, you can update it. But this is a tool. It's not a class exercise. So you don't necessarily have to redo it as you go along. It's not a deliverable product, except in class. So let's take a look. The undesirable situation. The undesirable situation is nobody seems to be able to overcome the perennial problem of poor requirements. Poorly written requirements are the norm in systems and software engineering. You see that tire on the tree cartoon and you laugh at it, but nobody is doing anything to change the situation. This results in failed projects called cost and schedule overruns, or the wrong system is delivered. And by the wrong system, I mean a system that doesn't meet the needs of the stakeholders, and that results in unsatisfied customers. But back in 1985, MIL Standard 961B described the grammar and vocabulary of well-written requirements. But it's been totally ignored, and Ivy Hooks presented Writing Good Requirements at the INCOSE International Symposium in 1993. The International Requirements Engineering Board has a certification in writing requirements, and I will relate this course to the IREB syllabus as I go along. There are lots of standards, books, classes, trainers, and workshops, and so on. INCOSE's model-based systems engineering is building complex and complicated models to produce a better set of poorly written requirements, instead of focusing on writing good requirements. And various requirement management tools still can't tell us if the requirement is poorly written or well written. Although I did develop a prototype tool for use in the classroom, and that's available on my website. So the assumptions I'm working on is requirements are an essential part of system development or the project process. Namely, we cannot deliver a system without them. And then I have a working hypothesis or assumption. Since there have been, and still are, many courses, books, etc. on writing requirements, the needed information to stop poorly written requirements from being created is not being taught in engineering and project management classes. And eliminating errors introduced by poorly written requirements has a greater effect on the delivered system than errors introduced in the rest of the system development process or the rest of the project. And this one seems to be supported because there's a lot of literature about the cost of repairing something is greater as you move further into the system development process. And so you fix the requirements and it's cheaper. And so fixing poorly written requirements is a lot more cost effective than trying to fix what has already been built. On the other hand, contractors may not care because they get paid to build the wrong system and then they get paid to fix it. No wonder they love Agile. So what's the feasible, conceptual, future desirable situation? Well, the assumptions are valid or not. I understand some reasons for the difficulty in writing wrong requirements. I've created and taught an innovative course on writing good requirements. Systems and software engineers are learning how to write good requirements, resulting in more successful projects, namely cost and schedule estimates are met, the system as delivered satisfied the needs of the stakeholders at a price the customer is willing to pay, and which of course results in more satisfied stakeholders and customers. So this is what the systems engineering process will look like, or the software engineering process will look like in that situation. And notice how the joke has disappeared. Well, this may not be true because even though everybody throughout the process understands the requirement, I'm not sure how the customer is going to be billed or supported. So those two figures may be the same or may be slightly different. So what was the problem? What needs to be done to convert the FCS to reality in reverse order? Well, FCFDS is I found out that the assumptions are or are not valid. Before that, the system and software engineers, that's my students, are creating sets of good requirements in the workplace. Before that, the students understand what they need to do and how they need to do it to create a set of good requirements. Before that, I've taught the course. Before that, I've created the course. Before that, I understand the pedagogy of effective and efficient learning. And I've been researching that for more than 20 years. Before that, I compare what's currently taught with what needs to be taught so I can identify the gaps and put in what needs to be taught. Before that, I understand what needs to be taught. And before that, I perform a workflow analysis on an ideal requirements elicitation and elucidation process. And before that, I have to conceptualize one. And before that, I understand some of the reasons for the perennial problem of poor requirements. I'm not guaranteeing to understand all of them, but the ones I do understand are the ones I can eliminate. Before that, I note lessons learned from prior requirements engineering research and experience. And before that, I bring the research. So here's an example of not only what I did to create this course, but tackling the problem, understanding the what's in reverse order. Okay, that's it. Any questions or comments? And remember, when registering the course, use the 3 words, the little one, as the discount code. I hope what you've seen here and what you've heard here will interest you in taking the course. And I look forward to seeing you in class.